Yes, guys, we are going to back to our channel and we are going to discuss about the derivation part of an equation of motion. So, derivation part, derivation of equation of motion. So, equation of motion. So, how can we define the derivation part of an equation of motion? So, as we know very well, very first equation we have discussed is v is equals to u plus at. Then second equation we have discussed s is equals to ut plus half times of at square, and at the third time we will consider as v square minus u square is equals to 2 times of a into s. Okay, so keeping these equations as a consideration, we are going to talk about the graphical method to represent about the equation of motion. So let us draw a graph between velocity time, slope graph, slope between the velocity time graph. Velocity time graph. So how can we draw this diagram actually? We are going to draw by drawing a straight line graph through this curve. And this is my y-axis, as you know very well. This is my x-axis, which you know very well. This y-axis will consider the component called as velocity, and this term we are going to consider it as a time. Okay, so here we are going to draw a slope also. This is my slope, I will consider there. So which is the starting point? This is my origin section, which is considered as O. Now since it is a starting point, so I will consider this is my A, and this is the ending part, so I will consider this is my B, and we have to draw corresponding lines. So corresponding lines will be drawn in this sense. So this is my corresponding y. Since it is parallel to y, so it is corresponding line. Since this line is going to touch the x-axis, it is parallel to x. Okay, so here also I have to draw a parallel because it is a starting point of an graph. So this point I will divide. This is considered as B, this is considered as D, and this point is considered as E. I hope you will be very clear. So with this graph we are going to define these three equations. The equation first is v is equals to u plus at, s is equals to ut plus half at square, v square minus u square equal to 2as. Now the question goes is the slope of an velocity time graph. We are going to consider here certain parameters. So what are the parameters we are going to follow here? We are going to follow certain parameters, which is nothing but OA. OA is equals to u. I have to write OA is equals to u. Next, I have to consider O to E, which is considered as t, time axis t. Next I have to consider B to D, which is considered as AT. That we will come to know step by step. And the next section we can also write OA is equals to DE, which is also called as the U. Which is also called as the U. So both these terms are same. Next we are also going to talk about the equation, which is nothing but the E to D, that we D to E is considered as U. Next we are also going to discuss as O to E is considered as the T, or otherwise called as A to D is also called as the T. So both these terms are same. So let us define the first equation for our first equation of motion through this derivation part. The very first part we are going to discuss is acceleration is equals to slope of velocity time graph. Slope of an velocity time graph. Okay, so which is, I can also write it as A is equals to, since I know that what is my A here, O to A, which is considered as the A, even we can write that also, O to A considered as the O to A is considered as U. So I will write it as A is equals to dB divided by A into D. D to B divided by A into D. I have to consider the slope part. Even I can write it as y by x. Even in this sense also I can define the equation as y by x. Next I am going to talk about dB can also be written as E to B minus E to D divided by AD can also be written as O to E. O to E. So E to B and E to D. So even I can write it as EB minus ED, which is also called as V minus U. So I will substitute this equation as V minus U divided by AD. Who is my AD? I have written here. AD is equals to T. Since you know that AD is equals to T. So AD can also be written as OE is equals to T. So if we substitute this T value here, so it becomes A is equals to V minus U divided by T. Even I can also write it as V is equals to U plus AT. This is my first equation of motion. I hope you will be better. I hope you will be very clear by seeing this equation. Next, we have to go ahead with the certain other parameters also to define this equation. So this is the derivation part of first equation of motion. So this proves that first equation of motion. This proves that first equation of motion. Okay. So since here we are very clear. Next we are also going to talk about A is equals to dB divided by AD. Since we know that dB can also be written as OE, O to E. So we can also write it as A is equals to dB divided by T, and at last I can say that dB is equals to A into T. This is also part of an first equation of motion, which will help me to calculate the second and third. I'll consider this equation as 1A. Now we are also going to talk about the same equation, second equation of motion, by the process called as distance travelled by the object in the time t. So let us talk about the second part, distance travelled. I have to write this derivation part, certain running matters here. Distance travelled by the object in time t. Distance travelled by the object in the time t. Okay. So what is the distance travelled by the object in the time t? So let us talk about this, and going to talk about this equation. S is equals to area of the trapezium. S is equals to, what is area of trapezium? The area of trapezium is OAB into E. This area of trapezium can be segregated into two parts. One is area of rectangle plus area of triangle. Area of rectangle plus area of triangle. I have to write in this sense. We will see step by step so that you can understand better. Area of rectangle plus area of triangle. Sir, what is area of rectangle? Area of rectangle is OADE plus, what is the area of triangle? Area of triangle is ADB. So let us talk about area of OADE. What is this area of OADE? That is nothing but L into B. Area of rectangle. Area of rectangle is L into B plus area of ADB is nothing but half times of B into H. I hope you will be very clear. Sir, this L into B can also be written like, you can see OADE. OADE means this part. We can define this part, right? We can define this part, right? So we can write it here. This is my length, this is my breadth. So I can write it here as OE into OA plus this is my area of rectangle. Now area of triangle, can I write this part? Can I write this part? Area of triangle, can I write this part? So area of triangle will be considered as ABD. ABD means this is my base and this is my height. So I can write here base into height means DB into AD. So I can write it here as half times of DB into AD. Correct only na? Next, what is this OE? OE is considered as T. What is this OA? It is considered as U. Next, half times of what is this DB? DB means what I have calculated here. DB is already calculated, sir. DB is equals to AT. DB and this AD. What is this AD is called as? AD is also written here, sir. AD is nothing but the T. AD is written here as T. So I will write it as AD as T. Okay. So next, I can substitute this. Rewrite this equation UT plus half times of A into T square. Half times of A into C square, T square, which is equal to S. So with the graphical section, we have derived this equation that is called as S is equals to UT plus half times of AT square. Clear? This is the second equation of motion. Next, this is how we can derive the second equation of motion. This is the step for defining the second equation of motion. Next, we can also try to do, this proves the second equation of motion. So we have to write this equation part. This proves the second equation of motion. This proves the second equation of motion. Now we are also going to talk about the third equation of motion. Let us start the third equation of motion as well. So distance traveled by the object in the time t. You have to write this statement. Distance traveled by the object in the time t. In the time t is, you have to write the same derivation in a different style. So we can also write the distance traveled by the object in the time t. So let us go ahead with the next part of the equation, that is S is equals to area of the trapezium. Area of the trapezium. Sir, what is this area of trapezium? The area of trapezium part will be same as it is as OAB into E. Now I have to write the equation in the form of an associative law. That is nothing but half the times of OE into B. E into B plus O into A multiplied by O into E, which is also considered as the equation as half. I can also say that half times of V plus U into time t. Sir, who is this EB called as? That EB is called as that is V distance. This is my U distance, this is my V distance. So EB is called as the V. Next, I can also write it as OE is time t, as we know very well. Next, I can say OA. OA is U, as we have discussed here. Okay, so V plus U into T. Now, I can also write OE is equals to, I'll give you a small clue there. We know the equation of motion, that is nothing but A is equals to dB divided by AD. So we have written here as dB divided by OE. So we can write it here as OE. Even we can write A is equals to EB minus ED divided by OE. Correct only, na? Now take this OE that side. OE is equals to E to B minus E to D divided by A. So this is the OE I have to substitute here. this point I have to substitute here. OE I have to substitute here from the first equation of motion. I got this equation from the first. So OE equal to EB minus ED by A. So that is nothing but half the times of V plus U into this OE. How can I write here? EB minus ED divided by A. Correct only na? Next. Sir, can we rewrite this equation? Yes, you can rewrite this equation. EB plus OA can also be written as ED only na? OA is also written as O to A is also written as E to D. So EB plus ED multiplied by EB minus ED by A. Correct only na? Next. So half times of, this is looking like A plus B, A minus B. This equation is looking like A plus B, A minus B. What is the formula there? A plus B or A minus B, which is also called as A square minus B square. So I can write it as EB square minus ED square by A. I can rewrite this equation as half times of V square minus U square by A, and finally the equation will be V square minus U square by 2A, and the derivation part will be V square minus U square is equals to 2A. Yes, this proves the third equation of motion. So this proves the third equation of motion. Third equation of motion. Okay, so we will recollect or recapitalize all the point. See, this is the graph between velocity and time. I have to put some parameters. This is O to A is U, E to B is V. Since OA is also equal to DE and O to E is also equal to T. So this is the parameter we have to follow. Since we have to define the first equation of motion, slope of velocity time graph, through this derivation part. So we will get the first equation of motion. After this, we have to prove one more part to define dB is equals to AT. That will help in the second equation. In the second equation, I have to take trapezium, then trapezium divided into area of rectangle, then triangle, then substitute the values. Formula, you have to substitute formula. Area of rectangle, L into B, area of triangle, half BH. Substitute the parameters, get the second equation of motion through the graph. Now go back to the third equation of motion, distance travelled by the object in the time t. That is area of trapezium, OABE. Same equation but in different style. So to define this OE, I have to take the help of this equation. OE can also be written like this, that OE has to be substituted here, and this equation will behave like A square minus B square. And at last I will end up with the third equation of motion, that is V square minus U square equal to 2AS. So with this I can prove that graphical method, derivation of an